Status, extremely efficient status reports will now begin.
Yeah, we just want to whip through this to make sure we know where things are.
Okay.
Maybe actually I had two announcements. One announcement is if you want your deposit back for your access card, and the other thing is for those of you who happen to be around tomorrow, there's a number 30 seminar at MIT, which Fernando is going to be at 4 o'clock. If you want more details, see me or you can look it up online.
How many people are going to be here through tonight? Did you guys watch Heroes last night?
No, we can
watch it tonight.
We can watch something more current.
Okay, status reports. Quick. So I think our goal is to finish by 2:30. Is that reasonable?
That's our aim. Yeah.
Okay. So we have to be fast. So the first status report, how about NTL wrapper? Can anybody say anything intelligent about the status?
So the NTL wrapper is supposedly within epsilon of done, but it's been within epsilon of done since the second day of this conference. So the issue is that we sort of broke it up into pieces, and like Joel was working on part, and David Harvey was working on part of it, and I was working on part of it, and Rob was, several people were working on it. We're kind of trying to merge that all together, and kind of each time we do a merge, the combination of things breaks some doc test somewhere, so we have to go start finding problems and fixing it. But up to possibly doc testing all of the new NTL code, it should be ready by tonight.
Awesome. Did you guys? That's amazing.
No,
so this won't include ZZP or ZZPEX because I haven't.
Right. Okay. Yeah, we don't have David's code in yet, unless it's ready to go. In which case we can.
But something will be ready to go.
Yeah, we should be able to replace it, and it adds a fair amount of new functionality pretty soon.
Awesome. Okay, great. Okay, elliptic curves.
So I've actually
David, yeah, let's see.
So now Sage has residue fields for number fields. Which is one of the things I needed for Kate's algorithm.
Okay.
So I'm making progress on implementing that.
Also, the splitting of the elliptic curves file, what's the status of that?
That is done.
Okay.
It's just on my thread.
And you merged in David Harvey's changes now?
So David Harvey's changes are in, the files are split. I'm making progress on the...
Okay. I need to apply that as soon as possible because if anybody changes anything in the elliptic curves, it can get lost. So that needs to get out in the next version, the splitting. Okay.
When does the next version?
By in, does that mean it's
probably 2 days
available, or in means it's been patches?
I think it means that it's in the release that everybody is using.
Okay.
So in other words, in 2.8.6. I'll release 2.8.6 sometime in the next few days. Sorry for the vagueness.
Are we going to start merging tonight?
Yeah, it's probably a very good idea for me to. So I'm not particularly involved in any project, so me just sitting there merging in other people's stuff is generally the right thing for me to be doing at any of the Sage days, actually. So that's my plan for tonight. Yeah, we can just start. We can make the first push towards 2.8.6 tonight. I think. Okay, so excellent. That's good. What about period lattice stuff, Jen?
You
guys are. Oh wait, sorry, no, Jen, right behind you is doing some stuff with period lattice.
Yeah, the two of us. I also have that.
Okay, excellent. Wonderful. Okay, sorry, Ben.
Okay. Dimitar is publishing his code for new classical figure points.
Awesome.
I think he's making good progress on that.
Yep.
Figure points making sure work parameterization, these kinds of things. We'll have to wait for more for the package on the edit arithmetic. So this is the pushing modules.
Cool. So did you use Sage at all yet?
I've used it personally, but I haven't put everything in code for it.
Cool. Excellent. Very good. Okay, so that's elliptic curves and kinetic arithmetic.
I got distracted by elliptic curves. I had some good conversations with Niels and Carol, and so I had a better idea for some difficulties with Krasner's Loa that I straightened out with Niels, and some stuff with the other polymers.
And I started cleaning up some code that David got from some other guy, and I sent you a patch by email, but it's not on track.
Who's that some other guy's name?
Matt Ince. He's an undergrad at MIT.
Okay, thank you, Matt Ince.
He's not here.
No, but maybe I'll watch the video.
Yeah.
Well, it's good to thank people. Okay, tensor products, questions, etc. of free modules or Suresh.
Suresh is
not here.
Not here.
Has left the building.
We've got a little bit done for quotient modules. You can build them, but can't do much with them yet.
including quotients of Z mod?
Yes.
And you also
Building them doesn't mean a whole lot.
and you
The
also
code runs essentially.
you also discovered and improved other things in
Yeah,
the
the,
course of your class.
Yeah, there are a couple of problems with some polynomial rings, but hopefully that's fixed.
Excellent. Okay. Next one is the stage back interface we did nothing. Okay, LLL, Martin.
Okay. So Damon's code is in, or at least there's a patch doing this, and as you can see, this can be quite fast. And it also, this is the example from the Magma documentation, and so we beat them on their own example. But
well, that's great.
And but the tricky part now is to come up. The really cool thing about Magma is that kind of chooses a kind of good LL for you. And there's some documentation on this by Stella.
Was there like 8 possibilities, or are there infinitely many possibilities for what good means? Just out of curiosity.
We have a state diagram, diagram.
But I mean, how many different? Is it like you could run 16 at once, or is it like there are a whole bunch of parameters that you have to tune?
Well, in general, there are infinitely many parameters, but I think they have a quite limited subset they actually use for this. Right. But this requires some changes to the underlying LL implementations because we need some more data from them. And
so you'll have to hack into all this stuff.
Yeah, and for basically the stuff we try to develop the heuristic on. Pretty much in every case, Magma was quite fast and we were quite slow. So
you should choose different cases.
So yeah, this would be the logical next step. But some machinery is there, and you can even check if something is already used, and stuff.
Okay, David,
does anyone personally know this guy?
Yes, Damian Staler.
Okay, did you tell him that we're putting this code in?
Okay, I mean, I think I had suggested that you invite him to the stage station in Bristol, but I don't know if anybody listened to me in Memphis.
We can try.
I just think it's a good idea in general to tell authors of code like this.
I was planning to do this.
Okay, cool.
Yeah. So yeah, everybody's happy when the code gets stuck in projects. Okay, so let's see. Anything else to add? There's a lot here.
This is just try to document what the heuristic is, the stuff we try to work with.
Okay, cool. All right. Actually, I did, Gonzalo Tenario and I did an evening coding sprint a couple of days ago where we greatly improved some aspects of the Perry C library interface in Sage. So now what it does is, if you run out of memory, it automatically doubles the stack and redoes the calculation completely transparently to you. It also deals with certain other errors a lot better than it used to. So there's some improvements to the Perry C library interface that are actually really, really nice in the long run. So hopefully you won't notice anything because it's just working now in ways where before you would notice something. Okay, Coleman integrals and p-adic heights on Jacobians of genus 2 curves.
So we haven't. So there isn't that much more code than there was. There have been some code improvements. So Robert twiddled with the Coleman integration code so that it no longer has to compute a Teichmuller point, which is a sort of a necessary change in order to be able to do integrals in bad residue disks. But
so during the talk, I had the impression it wasn't a necessary change to do that.
Well, it's a necessary change for the bad residue disks because the problem is that you have these functions that only converge near the boundary of the bad residue disks, and the Teichmuller point is going to be smack in the middle.
Oh, I see.
So you need to not rely on it.
I see. Cool.
So.
And it actually works better.
And it works slightly better. It gives consistent answers and is slightly faster.
Nice, very nice.
However.
So, what was?
Well, I mean, however, to do this bad residue disks, you need ramified extensions.
Yeah. Well, so we're going to need. We're going to need a lot of. In various places, we need extensions of the p-adics. So in order to be able to work in bad residue disks, we need extensions of the p-adics because we need to be able to be close to the boundary.
Well, it's the first time anyone using Sage has said they need extensions rather than they want to.
No. Well, we're not going to be able to do anything with that. We're not. This project is going to be
Because
completely
usually it's
stalled
been
with
sort of Nils and David Cole going, yeah, there better be extensions.
that. Yeah, no, even to do stuff over
No, for
QP,
completions, you need them.
I don't, no, but there hasn't been an actual calculation where
This
somebody
calculation will not.
desperately just
will
needs
not
them to go
proceed.
forward.
By the way,
Anyone
Even
who's
over
actually
Q,
said they're going to do
even over
extensions.
Q, this calculation cannot go forward without
the
grand
stuff
finite.
on finite fields that I've done means that once I have extensions, completions will be really fast.
Awesome. Okay, I mean, it's just, that's what really
Yeah.
drives things.
Um,
David, you have a comment?
I was just going to say I'm just implementing one tiny stupid case now, and if it was there, I'd be happy.
Awesome. Yeah. I mean, we had them before, right? They were just turned off because they were a little broken. You know, broken.
But we have a
It
list.
was working at one point.
We have a list. I don't know if this list is written down. I will make sure it gets written down. Of things that of things that we now know how to do and know that we need to do but haven't done yet. Yeah, I should put it on that page. So, for instance, one of them is making the tiny integrals code work in Weierstrass disks. That hasn't been done yet, has it?
No, not yet.
Okay, so that's one relatively easy thing we need to do. And then there was the thing I told you about this morning of taking a rational function which has only poles in Weierstrass disks and expanding it as a power series. That's another relatively easy thing we need to do.
So, I mean, once extensions are done, can you just kind of...
No, those things are independent of extensions.
Right, so
Those are things that we can do now.
would your code work if extensions were done right now?
No. I mean, there's more to do than because we haven't written anything yet to try to use non-existent extensions. Because I mean, we're not going to do that until we're going to try to do that until you have them. But there are other components that don't depend on extensions that we can do now. Those are two of them. And then we also have to sort of physically implement the sort of local index calculation that I'm on sketch.
And then I think, and then in the end, there's actually some theoretical questions about what's the best thing to do at the primes which do not divide the network limits. So the algorithm that I sketched is one option, but I think the problem with that is that you're going to have to factor factor some integers together. So in some ranges it will work well, and some others. I mean, maybe there's a way around that that we haven't completely figured out.
But certainly it's something we could try.
Yeah.
So so I'm gonna. So yeah, I'm gonna update the wiki page accordingly.
Excellent. Okay, so the next one, divisor arithmetic. Oh, Niels.
Yeah, well, Sage has not improved in that respect at all. But I did look at it a little bit. So we already knew that there was something for curves over finite fields, which seems to be broken.
The other Brillouin theory, singular.
Exactly. So what probably is going to need to happen is that at some point when the quotients of free modules, for instance, are more functional, someone should probably just implement Brill Noether. That could actually be a nice student project to do, because it's a well-documented algorithm. We could see how that works. I suspect that in order to get good performance, you'll need some number theory approach after all. So that's finite dimensional extensions of base field adjoint T and compute in those finite extensions instead.
Okay.
Yes, what about Hess's algorithm? You know about this? There's an algorithm by, I think, Florian Hess.
Florian, yeah, that's what I described.
That's
That's basically the method that you use to compute class groups in number fields, but now applied to function fields.
Cool. Excellent. Okay, this. Do you want to say anything, Martin, about why you nixed matrix mod to dense windows?
Yeah, this trust is broken. The matrix, the window stuff is used by Strassen multiplication and raw echelon form via Strassen. And the Strassen doesn't necessarily give correct results. And also implementing this matrix window mod too dense is, well, it's a bit more work than just, because you want to work on the bits directly and you have all these offsets, and so it takes a bit more work than sitting down for 2 hours.
Okay.
So I stopped working with this.
Although the breakage of Strassen stuff is very relevant because I think it's used somewhere in Sage for other things. So I wonder what the deal is.
Martin pointed out you spot the failures over small finite fields. So it seems like generically over large fields or if you cure something, maybe it's okay and there's something funny going on small.
Yeah.
But we haven't looked at it.
Yeah, we need to look at that because if there's a bug sitting there, it will not be good.
Well, I would assume that just the probability that the submatrix is singular is bigger than something that.
But shouldn't that lead to something like an infinite loop, or in practice it just not terminating rather than giving false answers? I didn't think your algorithm gave wrong answers and said it was correct.
Well, did you try it on small finite fields and lots of random tests?
Apparently not.
This is the inversion or just multiplication?
This is inversion.
It's the stress and...
I have a ticket on
Stress and echelon?
Click on it.
Yeah.
Okay. That should be checked.
I mean, it's probably just a real bug.
Yeah,
Yeah.
so
The algorithm is wrong.
yeah, that's extremely, I mean, that means we need to make sure right now that it's turned off completely in Sage by default, and then you guys need to fix it, because you guys invented the algorithm that's being used. So, yeah, that's not good, because that's not the expectation from that algorithm.
Is that used in linear algebra stuff?
It was written to be the underlying linear algebra engine, but then Linbox supplanted it in most cases, as far as I know. I mean, often, like the timings just turned out Linbox was like an order of magnitude better, and we ended up just using it instead. However, it's certainly possible, since the code's all there, it's entirely possible that it's still used in, over some base string or something. I can't remember. Do you remember it all, Albert?
I think it's used for like very generic base.
Wow. Yeah, that could be a problem. It's used for generic base strings and it's wrong. You didn't look at multiply. Maybe multiply is being inverse is bad or something. It's possible. Oh,
We're
Michael.
still talking about mod 2? Linbox is faster?
We're talking about matrix multiplication. I was specifically thinking of matrix multiply with the integers, where Linbox is fast. There's Strawson was faster than our Strawson because they use numerical blocks at the bottom level, and we don't. Or I think we don't, right? Walker?
No, we don't.
That was like next on your list.
We got about the same time and realized Linbox was finally doing.
Exactly.
William, Suresh is here.
Oh, excellent. Do you want to make any
Talk a little more about
comments
So,
about modules?
up.
Here.
So at this point, we sort of, I think, have a decent idea of how we want to represent quotient modules in general. And it's just a matter of implementing some of these commands. As a whole, I'm a bit unhappy about the way the modules are set up right now. It's kind of hard to deal with them.
Fix it.
I want to. I'm sort of, that's one of the things that I'm looking forward sitting around and fixing it. At the same time, because I just wanted to make sure that the quotient started, I didn't want to touch it at this point.
Yeah, that's very wise.
Yeah, I want to fix it. Having said that, before getting into changing it, I'd like to get some feedback on what people think about modules or what things they want from modules in general.
More doc tests.
Sorry?
More doc tests.
More doc tests? Okay. Well, so I think if we sort of have at some point have some sort of discussion about what we expect for modules to do would help greatly, because it seems like at this point the way modules is implemented, somebody wants to do something and just put in modules and
exactly what I wanted to write modular symbols.
Yes.
That's exactly what it is now.
Yeah.
The minimum needed to implement modular symbol stuff. It's exactly the subset I used of modular functionality in Magma.
Yeah, so I think that's
could be there.
It's not a bad idea to start thinking a bit about how we want to design it and then re-implementing it.
Yep. I don't know if it needs to be re-implemented.
Or just changing it a bit, yeah.
Yep.
Actually, for development of things like this, if someone implements something that claims to be a module, it might be nice if there's a set of generic tests that sort of test whether the fundamental intrinsics that modules are supposed to have are available and whether
it's just derived from module and overload.
Yeah.
But deriving from doesn't say at all that the things you've put in there behave as they should. They should perhaps
you can have an abstract base class and then define all the methods that should be defined in the derived class. and then make the definition be raised not implemented error.
Exactly.
And
So
then make sure
if you have a
page,
page,
that calls it all.
But
So-
for
yeah,
testing
exactly.
purposes.
But actually, I've done automated stuff like this, like when implementing matrices, I wrote a script that just, when you make a new matrix class,
Yeah.
I listed these are the methods you must,
Yeah.
there's a file for matrices that lists these are the methods you must override. There's
Yeah.
level 1 where you have to do it, maybe it's level 0 where you have to do it. Level 1, you better do this if you want it to be dog slow, but it will still work if you don't. And level 2, other stuff like echelon or
Yeah,
special.
that was a really
algorithms.
useful file.
Yeah, and I also, personally at least, I don't know if I supported it, but I had a script that if you made a new file, it would check that at least the level 0 things are down. So yeah, I totally agree with you.
Yeah.
And so you should look at what's done with matrices and look at the file that describes that, and then come up with something similar for modules.
how do people find out the existence of things like this?
How did you find out the existence of that
I
file?
read the source code for Matrix.
Yeah, it's just sitting there in the source code directory for matrices. It has a kind of obvious name. I don't think it's completely obvious. Just say, read this first, you person who's looking in this directory.
Maybe. I mean, I started reading the source files and they pointed me to that.
Yeah, exactly. Like if you look at any of the currently existing implementations, it says we're implementing stuff using the template that's described in that file, I think. So yeah, that was a critically necessary thing to do in order to get the matrices going. Because it was just stalled. It was so hard to organize it all. And I sat down and BAMF for many hours one night and just organized that. So yeah, exactly the same for modules. But don't do it until you've hacked around and looked at the code a lot, because you don't know what it's supposed to be first.
But another question that I have about things like this is that, for example, I created a class called, we created a class called quotient module and quotient module element. And I'm not quite sure how to start using it generically in Sage. Like for me to create to use that class, like when I put it in the library, it is something that I just don't
This has
know.
nothing to do with modules. It's just a general question.
No, this is just a general
about
question. Let's say I sort of create some new
This is not a
structure.
status report thing.
No, this is not a status
afterwards, because we have to finish.
Okay, so go on.
25 minutes or less. So.
But can I ask one sort of intermediate question? The hanger points people, are you guys going to, I mean, you said Dimitar was writing, so does that all, I mean, are you going to put information on the wiki if I want to read about, I mean, I'm one of the parenthesized people, I think, there.
Yeah.
I would like to know what happened. Are you going to put stuff on the wiki or?
Dimitar specify exactly what he's implemented and what's going to be available.
All right, cool.
And I think Dimitar is writing a .sage file under Windows, and it's working nicely. No, it's working very well. I set it up so you had a shared file system between Windows and Linux via VMware. So he gets to use Notepad and edit. I also slightly modified Sage so it's okay if you load or attach a file that ends in .txt, like .sage.txt. Because we spent like 10 minutes trying to figure out how to create a file that doesn't end in .txt in Windows. With all kinds of editors, it's very difficult. He said the way he finally could do it was using the command prompt, but in Windows, but it's just too hard for most people. So we just changed the notebook so you can load and attach things.
You can click on it and just.
I mean, is it just strictly .txt?
But the editor, whenever you save a file, it just appends it again. It's crazy, these editors. Windows really likes TXT extensions.
They want to help.
Anyways, so that's
So I just remembered, I had a follow-up question back on the Hager points thing.
Please.
And it's for Crit. So you were talking to Rob earlier
Yes.
about overconversion
Oh, yeah, I mean, I
module
guess I
symbols.
should mention
There
that.
should be some there should be some follow-up on that.
Yeah, so Rob and I are going to talk again at 4, and then I'm going to start implementing some of his code, hopefully in the next like 2 weeks.
So he told me also, I talked to him, and he said that what he implemented with Glenn in Magma was for a very difficult edge case. So their code was really, really hard, and that for most situations of interest, there's a significantly easier thing to implement,
Right.
which builds on modular symbols.
I'm
So-
starting with the easy modular symbols
Yeah.
extension because I know the modular symbols code now.
So it looks like we'll get something that will be really useful for a lot of situations very soon. Or a reasonable
Yeah.
amount of
So
time.
yeah, I mean, I'm going to start working on this just because, and then I probably won't add it to this, but as soon as stuff is available, I will push it into Sage, and it'll be in the change logs.
Sure. You should make a track enhancement if there's one already. There probably is already.
Yeah, I will at the end of the day once I have a.
Yep.
Or maybe I'll make one right now that just says something very generic.
Yep.
Who's able to?
Quantities parse linear algebra. Yes.
Mark
So,
that.
what happened with that, Mark?
Yeah, well, the code is available at the URL provided when you click on it, and it doesn't give you raw echelon form, but solves for 64 random vectors in the cosmos. But that's
So you can just do it repeatedly and recover echelon in some cases using the algorithm we were talking about, or no?
I don't know how. Really.
Why not? I mean, once you have elements of the kernel, let's see, that's a good question. Well, You need a brain cursor, so you know when it's done. How would you know? Yeah, you're right, there's a lot of trouble with that. Just compute the echelon form of all the vectors you're getting out. Huh.
But might still be relevant, right?
Yeah.
So
a lot of problems where this is useful.
it's supposed to be very fast.
Okay. Cool. 64 random vectors in the null space. Oh, did you have any comments about speed?
No, because I didn't try it, just the leaf though.
It's so specialized. All right, comments, questions? Excellent. But not a shade. Okay, so bind singular over number fields. Or bind singular. You did. Okay, but you did something. You fixed the bug in bind singular.
Oh yeah, fixed a couple of bugs.
Excellent. Okay, mem leaks and Valgrind usage. Status report.
I haven't put the talk up yet, but I will shortly. And nobody has had questions for me yet, so I'm deeply disappointed.
Well, I heard several people tell me personally that they, like, one of their top 2 things that they really liked about the workshop was learning about Valgrind and its additional features.
Yeah, well, I guess.
Not questions, but it was a very valuable
I mean,
talk.
I think, so, I mean, I don't know if I speak for other people, but for me, since I use a Mac, I'm not going to try and use Valgrind on my machine until 10.5. No, I know, but I mean, I primarily develop on my machine.
Yeah.
So when 10.5 comes around, I'm going to look up your slides and start using it a lot more. I'm going to be lazy until it's easy for me. And that might apply to a lot of other people's work. Because they'll have Valgrind in 10.5? Yeah.
That's at least the
supposedly, yeah.
Yeah, it's conjecture.
I think us
Justin
10.5
just nodded
is
that
good
it
at
was.
everything.
No,
No,
I was
Sage
agreeing
is
that it
very
was
basic.
conjecture.
It just, can we sneak Sage into us 10.5? That would really increase the distribution.
I think
Give it to him for free.
I got a little bit overwhelmed by the number of talks, and I think at Sage Day 6 I'm hopefully much better prepared and actually do more examples. I was kind of surprised that if these problem turned out to be an NTL and seemed to be needed.
Oh, did it? I didn't know. Oh, it was. Oh, that's what you. I guess
Yeah,
you showed that in your talk.
Yeah, it was like
NTL string conversion.
529,000 leaks on 8 bytes.
Yep. Yeah. Really leaks that up, don't they?
And well, if the NTL update gets merged for 286, I'm going to see if another problem pops up. Otherwise, it's going to fix. It's trivial to fix. We've done it before 2 or 3 times in the NTL code. So.
And then we should fix things so that function doesn't exist.
I think that's already happened. Which function?
Yeah, but it's not merged yet, right?
No, it's not merged.
Yeah, so once you start merging patches,
then it's a lot easier for you to deal with it.
Yeah, so if they can not waste most of memory on SageMath.
Yeah. Yeah. It's really a sad waste of resources. Okay, so let's see. I think that is it. We have finished early. Does anyone have any other status reports that weren't mentioned here that they want to make comments about?
Can you go to my home directory in sage.mas and I can show you the beautiful inheritance tree of Sage.
Okay.
Oh.
So any actually, we have 20 minutes.
It's not. It's a graph.
Any quick 3-minute lightning demos?
Wait, as Martin loads, can I ask a 3-minute question? Or a 30-second question?
Sure.
So you
Martin
said,
loads pretty quickly.
Right, well, you said you're going to start putting together 286 tonight. So
that's
if we have a handful of random tiny patches, should we start giving these to you now, or will
No,
you?
we should start making track tickets and putting with patch and putting there and describe what they do.
Okay.
Doc test.
Yep.
Yeah.
Making patches that really work and don't have your secret stuff hidden in them, because I'll.
Hidden in 57,000 lines of code.
Yeah, like Saru sent me this.
What is that?
Saru sent me Saru sent me a harmless seeming patch, and it happened to have all your Swan stuff in it. It's really fun.
Really?
It's an NTL
Did you apply my SCON stuff?
Yeah, like a month
On a
ago.
bug day.
During a bug day. So that got snuck in almost again, but it didn't. It's kind of funny.
Now there's a really serious SCONs patch that needs to get merged. So.
Awesome.
Wow, that's Sage.
There's a T-shirt.
Yes.
So every time you design a T-shirt.
Wow.
So you use Sage object, you use element, and I didn't, put in enough work to actually.
How did you identify them?
Well, I put out an SVG, and then I used an SVG editor, which took like 800 megabytes of RAM. So probably I should just write an XML script for this. But I mean, it's really easy. We can actually write a script in Sage that puts up the actually you can print the names for the class you're interested in. And put like pass the little stuff in there. I mean, there's some work to be done. But, so this is like
You have an object, A that you got back from something. You can say A dot Stein will tell you how it fits into
It'd be
there.
great if that were live.
Yeah, what does live mean?
It's a Google Maps overlay.
Like a Java thing.
A Google Maps
And
overlay.
obviously, because
Yeah.
it's all laid
The more
out
you zoom
using
in, the closer you get
the
to the source file.
graph class, it's easy.
So, oh yeah, so you could probably export it to lots of your formats.
This is the 3D representation of the inheritance tree.
Can you make it spin around?
Not yet.
So are the red ones the ones with bugs in them?
Yeah, just one that don't have enough software.
You're right. I mean, you could do also, I mean, you could use a coverage, right? I mean, and then
Color.
draw the nodes according to the coverage.
Yeah, green.
That would be awesome.
We could just pinpoint somebody's at fault here.
I wrote some coverage things.
Oh yeah, this is awesome. Wait, I think we need to applaud for Martin.
So when do we get the T-shirt?
But yeah, so that's if you sage tab, that's the modules that are loaded in all.py, or in setup.py. So when he does it, he just goes over each of the, because you can get, you can tell
Well,
he's
it's
a key
just
in the
basic.
dictionary for that.
Like, once it's done this way,
and then
it's
just
faster
he just goes through and recursively calls that and builds the graph.
Back to parallels.
It's very cool.
Parallels is
I mean,
really,
because
it's
also the smart way to do it.
amazing.
The
It takes about 4 seconds when it's done at once already.
No. Wait.
I did a benchmark on copying
No.
50 megs.
Yeah.
It took 6 minutes on some parallels.
If you
It has like
directed
snapshot
that for you.
functionalities and stuff. So
Yeah.
oh, here it is.
No.
So this is Sage. These are all the files in Sage, and for each one, you see the coverage in doc tests.
Wow, yeah, it seems to be low.
61%.
I wonder why.
Some of them aren't so bad, actually, surprisingly. So if you've ever wondered what is the overall coverage of Sage, where, well, if you go down to the end, it gives that to you. So first, the total number of functions in Sage is 16,723. So we have twice as many functions as MATLAB.
What's the number of classes we have?
Roughly 1,800.
We have more classes than functions.
No.
No, 1,000.
16,000.
1,000, sorry. Oh, yeah, sorry.
On average, we got 10 methods per class.
And the overall coverage is 31% of our functions are doc tested. Isn't it bad as I expected? I thought it was going to be like 10%. So it's about 30%. Well, it is 31.3%. So this is a useful tool. You can run it on a given directory. So if you're sage reams pi, say, you can say sage dash
You forgot the E.
Just put it up with it.
William, let me ask you a question. Is it just is that a
Yeah,
different
so that's-
script than
I-
Sage Dash coverage?
I improved it. I modified coverage and I made a script coverage all, and it'll be in the next version.
Okay.
So this gives you just the summary on PIX, which is 11%, and like number fields used to be 100, now it's down to 67.6%, etc. So reams overall, 42%.
That's pretty good.
Yeah, not so bad. Modules, so stuff. So 42%.
Can you do modular? Just because
Sure. Because you're going to improve that one a lot. aren't you?
Yeah.
So I think this will be a good tool. So that's pretty good. It's like below average.
Yeah. Not for long.
Does anybody else have any requests?
Well, until you start writing all this over-converted stuff, that'll go
See,
down.
I'll doc test as I write it though.
Famous last words.
Look, graph 64%. They're one of some of the best things, and thanks to Emily, who writes a lot of doc tests for graphs.
Is there anything that's near 100? Like the combinatoric stuff, right? Didn't my doc test
looked
at
at
all?
the new code from
Yeah, that's
Mike
like
Hansen.
2,800 doc tests or whatever.
49.6%. Yeah. 50%. Yeah.
Tough crowd.
Yeah, it's hard getting these up. Groups, 46%.
What about schemes?
28%.
That sounds familiar.
That's better than I was expecting.
So is there going to be a hall of shame on the Sage master? Yeah, these are the 3 modules with the lowest coverage.
Musky watch sensor is 5%.
Yes.
We need to fix the
So
musky
we-
watch sensor, I
So
suppose.
only a few minutes. Is there anything somebody wants to show off, or that they did? Any other comments about status?
Is there anything regarding the news framework from Mike?
Not that I've seen.
But because if we're going to achieve coverage closer to 100%, Sage test always can run 3 times as well.
I'm not convinced of that. Because tests don't. Like gen.pyx, which has like tons, I don't know, I mean, actually I can find out.
Well, that's
a huge number of tests, but it's very
startup time of a second.
Yeah, pretty worse than on my machine at home. The startup time is ridiculous.
It's not
Yeah,
it's very
I mean, increasing the number of tests won't change the total time that much.
It's been most times 240 every
It's like the number of files. It's the number of files that's the problem. And this will reduce that a lot. I mean, that said, you could, of course, write.
Sorry, say that again. Something happens with doc tests.
No,
you could easily write doc tests.
Test or make test. Then Sage starts up, for each file.
So it's 150 doc tests there. It takes 3 seconds. I mean, there's a stupid 1 second, or for some people, 100-second startup time each time. And then I think that if we double the number of doc tests in Sage, I don't think the total running time would increase that much running all the doc tests because there's a stupid increment. Also, I mean, if I double the number in here, I would look to see which ones are taking. You might accidentally introduce one that takes 5 seconds, whereas the whole file was taking 3 seconds before. That one you shouldn't run all the time.
Yeah, because one of the elliptic curve doc tests takes like 100 seconds out of.
No, that's the whole file.
El rational field.
One single. There's no single doc test in the file. That
No.
So that's what he was breaking that one up. But there, it's. I mean, it's really actually like a 7,000 line file. It's really a huge package of code.
Okay.
One thing I want to have, by the way, is a comment hash fast or something for doc tests. It would be nice if you could doc test sort of the whole library in 5 minutes, but where the doc testing coverage isn't so good, but just to get a general sense of whether you broke something. So in other words, to mark a doc test as almost instantaneous to run, or some marking so that some subset of the tests in one file would get run only. And this would only mainly be relevant once we have a way to do all the doc tests when we start in Sage once. Once that's the case, then it would make sense to do that. And your hand's just not going down.
So I have a proposal with respect to that. So what about having an option for test that checks with Mercurial which files have changed since some revision and tests just those files?
The problem is that usually when you make a change in like NTL stuff, it's the integer code that uses NTL that you actually break the doc test in.
Yeah, it's almost always not. It's almost always useless to do that because very often you find that you change something in number fields and the doc tests that detected are in modular symbols. And in fact, when the thing that Robert did that broke quadratic fields, only everything passed except modular symbols. It was quite surprising, but it was really a serious problem. This is a lot more than 3 seconds.
But maybe that means that the doc tests for number fields are not good enough.
Well, I think it's because they test the obvious things, and if you make changes, you make the changes to the doc tests that are relevant. There's all the other things that expect to behave differently that create.
And there's nothing like doing generic, serious linear algebra algorithms over a field to expose issues with its arithmetic. Wow. Okay.
3 seconds? Sure.
That's right, because it's just taking 3 seconds. Here.
Is this the?
Maybe I have like a bunch of processes that are running from drawing all these pictures this way. Yeah, that's what's happening. I was drawing a lot of pictures. That's the wall. Oh, that explains why video is slow. So 6 or 7 seconds. But I mean, yeah, I'm surprised because I mean the number of doc tests in Sage is it's doubled several times, and it used to be not. I mean, it hasn't grown in time to be unbearable. The amount of time it takes to doc test the whole library. It's far from. I mean, it's still about a half hour on most machines, most fast machines.
Yeah, I mean even on my slow machine, it's only I think it's 5,000 seconds to do the whole thing. It's less than 2 hours.
Yeah, but it's kind of surprising it hasn't grown that much. And the reason is because very often I'll get files from people that do have doc tests that take a long time, and then I go through and mark the ones that take a long time, and then I only doc test the ones that are reasonably fast. And I do the long time ones only very rarely, like once every 2 weeks. That's all.
So the proposal version 2, so a file can say that it's relevant to test another file for it. So
you don't know that.
Implementation.
If you write the NPL code, you don't know what uses it. You would have to test all of the things you import.
The point is that you have something quick that you can actually run often while you are developing code.
Isn't that fast?
I mean, honestly, I have on SageMath or another machine, I just push out my code and I run it there regularly. And it doesn't take me any time. I don't even notice. I just look an hour later to see what I messed up. It doesn't take any of my resources really.
But when
so
you
easy
change
to
a line, I
patches
want to know if that breaks something.
Well, you don't know. Like even if you run all the doc tests, you might not know.
It works. I mean, having doc test works as a. I mean, it works amazingly well for keeping you from breaking stuff. But yeah, there's a lot of problems to it. Michael.
Yeah, well, I think it's somewhat of a pain in the ass if you have memory leaks, because I rerun the whole test suite after I do something, because side effect wise, you might touch something and then it just blows up on another end, and I really don't want to sort of patches that just make things worse. So I think overall.
Wait, I don't quite understand what you're. I understand what you're saying, but I don't understand why you're saying it. I don't, why are you saying that? What's the it in this sentence?
I think I will start looking into running the doc test in parallel. Because if I can take 8 CPUs on SageMath for like 5 minutes.
I think that would be a great idea. And 16 CPUs. Running them in parallel, there's no reason not to. Except, there's no reason not to.
But I think it plays together well with the demonizing the code.
And also, I mean, on a machine like SageMath, the startup time of Sage is, on a Linux machine, basically the startup time is vastly less than on OS 10 because it does file caching so much better. That's my experience. I can't even connect to the internet. I mean, it's like it's like 1 second versus point. It's at least 10 times faster once you've started up Sage already. So when you're going through the doc test, that helps with it. So running in parallel, you're starting up a lot of stages over and over again. But there's no contention between them. It's completely easily parallelizable.
Yeah, I might actually do it externally.
What?
I might actually do it just in its own Python, with its own Python script initially, and then just try to merge it back in or whatever.
You mean create a parallel doc test thing in Python?
Yeah, you can easily fork and so on in Python. That's not a problem.
Yeah, I think that's probably
so
a good idea.
So you have a master and
you could. It might be overkill though, because you have to set up the dsage environment. But it's a pretty natural thing to do in dsage. You should consider doing it in dsage, because that would be just send easy way to make sure.
Oh, this is, I'm doing the test and stress.
So anything else? Okay, so we're done with the wrap-up session. And officially, modulo working sessions tonight. The workshop is ended. Modulo, we're going to have working sessions tonight. All the formal stuff is done.
Last announcement? So make sure to make the announcement at the beginning so that I can forget.